name's Sarah and I'm a design engineer at Rolls-Royce. My job is to work with a really big team of people to come up with some innovative solutions to some really complex problems in order to come up with a final product that's safe and meets what the customer wants. Outside of work, I'm with a team called the Bristol Gulls. We're 4 women from Bristol and we've set ourselves the challenge to row unaided across the Atlantic Ocean in December this year. So just like my job, in our rowing team we need to come up with really innovative solutions to be self-sufficient on the boat for that long. Engineering is a really interesting subject. It can take you to so many different places. Before I joined Rolls-Royce, I'd never seen aerospace components before, and I've never tried to do something like row across an ocean before. So my advice to you is don't be afraid to try new things. Apply yourself to those things, try the best you can, and more often than not, those things will lead on to new and even more interesting experiences.
Hi everyone, my name's George and I work at Rolls-Royce here in Bristol. Now it's not the Rolls-Royce which makes the fancy cars, but we actually make jet engines to go in planes, which is a really cool job to have. So just a little bit about me. So I've started recently at Rolls-Royce as a graduate engineer, but already I'm being given real-world tasks and jobs to complete. Normally we have an idea, we design it in a computer, and we also try and test it in a computer using computational fluid dynamics, which some of you might have heard of. We then try and improve the design and do that lots and lots of times, so we end up with a really good design at the end. We then try and make it and stick it in a jet engine and test it for real, which is really exciting. Now if that sounds like a job that you would like, I really suggest that you try and take up a science or technology, engineering or math subjects, either at school or maybe in a uni or in an apprenticeship. But yeah, it's a great job and I love it, so really recommend it for you guys. Alright, that's it from me. Have a great day.
Hello, my name is Nigel Higgins. I work at Airbus, and if you haven't already guessed, one of the things I'm involved with is virtual reality. My body is being tracked to drive the avatar, and with a bit of luck and a little bit of VR magic, we can catch the glider. I'm one of the many examples where an interest in model aircraft as a 9-year-old led to a career in the aviation industry. This is a picture of me in 1985 with a model aircraft. I joined Airbus straight from school in 1987, and after completing my apprenticeship, joined the structures design department, where I was involved with most of our aircraft flying today, including conceptual design of the FLA, which flies today as A400M, and the A3XX, which became A380. I even have a patent from this work. I then moved to design automation, where as a team we were writing code to automate design and the creation of 3D CAD models. This progressed onto managing the mechanical CAD systems for Airbus Commercial, before my current role as a design process architect in the information management team. VR is one of my responsibilities, and that includes support at events. This is me at one event showing VR to Al Warden, an engineer who flew around the moon. As an engineer, you can expect your career to be varied, and whatever job you start off as an engineer, it is likely to change. And also, engineering steps across boundaries. Mechanical engineering and IT in my example. My advice to a budding engineer is focus on your skills and constantly develop these to keep up with the ever-changing world or new areas of interest. And rather think about a job you have and its boundaries, understand you have a set of skills and knowledge the world can call on whatever scope that may be. That just leaves me to pass on the glider.
Hello, my name is Ilham Saeed, an aerospace engineer and entrepreneur. I got into engineering because I'm passionate about people and technology and combining the two in a sustainable and durable way. My journey into entrepreneurship stemmed from a problem that I was facing as a second-year aerospace engineering student, wanting to find a solution to solve it. This led me to start E2E. E2E is a collaboration space for lecturers, students and industry to collaborate and solve problems in real time. You don't need a typical engineering job to gain experience in the field. A lot of valuable skills can be gained from participating in Airbus's competitions, joining a summer school in space mission design hosted by the European Space Agency, or even attending an international summer school. If you're interested in getting into engineering, start with small things, like simply watching how does it work videos on engineering topic that you're interested about, and by the time you know it, you'll be building something yourself. Think of it as launching a rocket. The further you want to fly, the more stages you need to have. As engineers, problem solving is an iterative process, and you'll eventually reach the solution that works. Thank you.
In 1908, when my granddad was about your age, he got the flying bug and he went to some of the earliest flying events in the UK. I still have his magazines from that period. In the First World War, he learned to fly and served with distinction in the Royal Naval Air Service, fighting the Germans in the skies over Europe. When I was growing up in the 1950s and 1960s, Grandad loved telling me all his flying stories, and he gave me the flying bug. I built model aircraft, and as soon as I could, I built a hang glider and taught myself to fly it. Later on, I learned to fly microlights and many other types of aircraft, several of which I built myself. I've even built an exact reproduction of Grandad's World War I machine, and I fly it at air shows. I love flying today as much as I did 60 years ago, and there's still so much to learn. How can we make flying greener? Can we go faster and higher? How can we use drones for everyday jobs? If you've got the flying bug, no matter what career you follow in aviation, whether it's engineering or flight crew or air traffic control, or if like me, it's just a hobby, you can be sure you'll enjoy every minute of it.
Hi everyone, my name is Priscilla and I study at University of West of England in Bristol, and I study aerospace engineering with pilot studies. I chose to go into engineering because first of all I love to do practicals and to do experimental things and just to get a bit of hands-on experience, and I love to do problem solving as well. Second thing I chose engineering is because I love maths, I love STEM, I love all the things to do with science and maths, and engineering is a great way where you can use that. And thirdly, I chose aerospace in particular because I love to travel, and since most of the traveling is done on aeroplanes, aerospace was a perfect choice, and so that's why I decided to go for this field. So when you study engineering at university, you're quite lucky because you get to look at all the different ways you can specialize. In engineering, it's three main ways. First is manufacturing, second is systems, so computers and coding, third is design. And I chose manufacturing, and for that I did a placement at Jaguar Land Rover, where I got to see how the cars were being made and also the general processes that you would use in the engineering field for manufacturing. Also with aerospace, it's not just about the engineering, you actually have the additional benefit of learning how to fly an aircraft, and this is something that I want to do in my future career. And so for that, in between my studies, I went to the US and I got my private pilot license, which will help me in my future career to be a airline pilot. So in engineering, there are many ways that you can specialize in, and it's all open, it's all available for you to go and find out which area really interests you.
I'm an engineering manager with a specific specialism in aircraft engines and propulsion systems, and that has taken me all over the world, from America. I travelled to a few states in America, all the way to India, and as far out as Australia as well. You don't have to follow the traditional route into engineering by going to sixth form or college and then on to university. I took a different path as an engineer. I went and did an apprenticeship, electrical at 16, undertook an apprenticeship at a small workshop, and that gained my foundation knowledge as an engineer really, and I used that then to take me forward into more of a design role later on in life.
Hi, my name's Emma England and I'm an aeronautical engineer. I calculate the forces and the moments on the aircraft during flight. So, what are the forces? As you're going along, you're going forward. That forward motion is generated by, normally on an aircraft, the thrust coming from the engines is just propelling us forwards. In the case of the glider, it's actually the forward force that's being generated by my arm. The wing is slightly angled and there's a curvature. And in this instance, it's generating a lift on the aircraft. This lift force will increase as we have more curvature or more angle, or the speed of the forward motion increases. We have that lift to counteract the weight. The mass times the gravity is pulling us down, like what's keeping us here on the ground. So the lift force is counteracting the weight force. Then we have the thrust force, as we said, which is taking us forward. And as we fly through the air, we're getting a rearwards generating force, which is a resistance of the air over the structure. And this is a drag force. We can reduce the drag by kind of covering up any laps and gaps, making our profile quite streamlined, so it's kind of cutting through the air. We could also play around with like the curvature, the profile of the wing. This changes the lift to drag ratio as well. We've added a bit of weight here in terms of the plasticine to get the balance of the forces. So when you give your example a go, you'll need to play around with that, because otherwise it's not going to necessarily fly straight and level. So now you've learned a bit about the science, it's your turn to have